Now we want to look at graphing these equations more accurately. So the first thing we've got to do is we've got to check our domains for each of these. So here, x equals 4t plus 4, y equals t plus 2. These, once again, are both straight lines, so they go from negative infinity to infinity. So I know my final graph is going to go from negative infinity to infinity. The one that's easier to solve in terms of t is the second one. So right here, this is going to be t is equal to y minus 2. So once I solve one equation for t, I'm going to plug that into the second equation. So I've got in my second equation 4t plus 4. I know here t is equal to y minus 2. And now we'll solve for y. So we'll distribute the 4 in. So you get 4y minus 4. We can add the 4 to both sides and then divide both sides by 4. So 1/4 x plus 1 is equal to y. And here the domain is going to be from negative infinity to infinity. Once again, the result is a straight line, and if my initial was a negative infinity to infinity for both those lines, there's no reason this one shouldn't be from negative infinity to infinity as well. So if I were to graph this parametric equation, we know it's going to have a y-intercept of 1. And I'm going to go up 1 and then over 4. It's the slope of 1/4. And as I said, it goes from negative infinity to infinity. So that's my entire line right there. And you can confirm that by going to your graphing calculator and plugging in parametric mode for your very first step. And then your final answer, go to functional mode and plug it in. The second one we've got to be very careful about. If I look at this first one, x equals the square root of t, the domain here is from 0 to infinity. I can't have a negative underneath that square root. The second one here, y equals t minus 5, that goes from negative infinity to infinity. But I have to choose the more restrictive domain. So my domain is, for the final answer, is going to be the most restrictive, which in this case is x equals, or excuse me, going from 0 to infinity. So let's start out by solving for t. And probably the easier one to solve t for is just by squaring this right here. So then x squared is equal to t. I'll then plug in x squared in place of t in my second equation. So y equals x squared plus 5. Now if I were to look at this equation by itself, I would say x squared minus 5 goes from negative infinity to infinity. But because of this initial restriction in step 1, I can only go from 0 to infinity. The most restrictive domain is going to win out on these. So here, x squared minus 5 is going to be right there. It is a filled-in circle because the 0 is included in the domain. And I'm only going on the positive side of things for my parabola. I do not include that negative side of the parabola. And we could confirm that on our graphing calculator if I wanted to do that. And I think that would be a good thing to do for this equation. If I go to my calculator, let me move this off to the side here, and then I go to my parametric form, my original is x equals the square root of t, y equals t minus 5. I'll plug that in, and if I hit graph, you can see I only have the positive side of the parabola. So you've got to be very careful with these domains that this x squared minus 5, if I were to plug this into functional form, I would get both sides. But since it's coming from the parametric where my domain is restricted, then I've got to keep the most restrictive domain in my final answer.